Hi, welcome to another video on my fischertechnik monorail, which is controlled by a BeagleBoard running Ubuntu Linux and a fischertechnik robo interface. Last time I reconstructed the carriage in such a way that it now has two springs with power conducting rods and another motor, and in several ways this is not an ideal construction, and I will try in this video to solve a few issues. One of the issues is the wiring, and another issue is this rod. Now when I take it off, you will see why, because although this is rather flexible, using this way it easily touches the power rod, and if you connect the ground rod with the monorail, which is also the power rail, then you have a short circuit, and that's not good. So like here, I'm going to change the position of the ground to the other side, and for that I have to try to relocate or to rewire this. So let me first remove the spring. Oops, that's not good either, but it kind of shows how things are at the moment. So this one has to go here, so I will shift it through, and then it is supposed to be like this. That has one problem. In some way the wiring has to be nice and easy, so if I shift this more to the other side, taking care of the rod not shifting too much. Alright, this one staying a bit close to here, then everything should work out fine. Then there is a little problem that I now notice, because it is hardly noticeable, but now the green version is too close to the rod, but maybe that doesn't matter. Another problem is, of course, the wiring. The wiring should not be able to touch the propellers and should not be able to touch the lights, and the lights are here and here, and as you can see the wires are pretty long. So the solution would be to have the wires like this, and that is the next problem to tackle. So how can this best be addressed? Well, by this, because you can easily put a wire in here, but oops, I will have to put it somewhere right there. So I have this, slide it on like this, and then the wire should go nicely in. And the advantage of this construction is that it is exactly centered over the middle, so there's no balancing problem. The only difficulty is that with all those parts together, it gets pretty heavy. But I will need to see how that ends up. Now, this wire connects both motors with propeller, and that is a different problem because it is too short to get here. So I will have to do it like this for now. But then when I look at the other side, that is a different problem, because this wire cannot possibly be dealt with the same. So I think I will put this somehow in here, and then like this in some way or another. Let's see how this ends up. Put it right here, don't touch the tripod. And this wire is thicker than the original fischertechnik wire, so that delivers a problem as well. It looks like this is giving a serious issue. I can't get it in. Oops. Yeah, that is, it is really thicker. So how to do it then? Making some wire and pull it in, I have to think about this. And let's pull this wire again. Now this motor has come loose. Oh boy. Wiring issues. Ouch. Alright, so is this functioning? Well, for now it is. But the other wire is still a problem. For now, let's just see how it runs, because that makes all the difference, of course. The big advantage is it won't make any shortage now because of this. And yeah, okay, hopefully this wire stays the way it is now. What more? Well, yeah. Let's run this first. Starting the software. And with both motors applied, it should give the same speed in both ways. The program is still running. I have no power on the lights now. I will show you. No power here. No power here, no lights. And for some reason it starts running again. I'm holding it back now. And with two propellers, I think I need a construction like on the other side. So let me show you. The other side has this catch where I catch the cone of the propeller so it doesn't rock, let me say it that way. So right now this problem is at hand. And still why is it moving slowly into that direction? It has maximum speed of the propeller, and I really don't understand why this is. Maybe, let me stop the program for a moment. If you look carefully, then it is not really stable. You can, let me shed some good light. If you look at this, it is easily taken out. It hangs a little bit, so I actually should improve this. The question is how? Maybe something in here. Let me just try that and take care of the wires. So the connection piece in here, but that also means that I don't have a connection piece in here, and this doesn't work. So I need to have it here, and I need to have it right here. So I should also put something here and on the other side. So yeah, but then again, putting the wheels right, start the program again. That way goes easy, and that way doesn't go easy at all. And even when I push it, alright, let's go there. The lights are not working, and the algorithm is focused on lights. And that's a problem too. Okay, let's first stabilize the motors. So to stabilize the motor I have two options. either this one or this one, and I think I'll first test this one. So I have to take it off for now. Careful with the wires. And once again I can only use the flat side, which is under. And also here, but here the cable guider is already on, so I'll have to shift it through. So let's see how this will work out. If it works out, that is one. Yep, they're all in. And this is much more stable. Much more horizontal. So that is one. And then we have to tackle the wiring problem. And for that I had another solution in mind. Just a blue binder. And I have no clue how this is going to work out. If it works out anyway. Experimenting is fun, but it should work out. So this is shortening it. And it already slides out. So the question is how this will work, and I'm afraid the answer will be it won't. Too close to the propeller. But what can I do anyway? And then this wire has come out entirely. So let's put this back again to where it belongs for now. Alright, a little bit stabilized. So let's try again. Again, to the left is fast, and to the right is, well, the lights are working now. And there it stalls. And I'm not touching it now. Alright, at the moment the velocity in both ways is about the same. But the time it goes in both ways is different. And how to solve this? That's a very good question. Now I'm holding it back. I'll show you. I have to hold it back before it touches this with the blade. Why does it stop? It does interrupt, let's see. Yes, it definitely does interrupt the light beam. But it takes way too long. So the timing in the program has ended way before something has happened. And that's a problem. With this software timing problem, which there obviously is, I have to go through all the sensors again. And this is the farthest. I don't have to look at that for now, because all that happens is between 6 and 7. Programmatically not that logical to have it in this sequence, but well, that came by growing. Another thing is this one, and probably I should have if T digital 6 and if not T digital 6. If not, then it is obviously that the motor is there. If the signal is there, there's nothing wrong. So why did I put a positive and a negative in the first place? This is negative and this is positive. Here I change the status. Here I change the status as well, by the way. I don't think I need to enable the positive one. This that control lamp, by the way, is mostly on, but I don't care for that right now. The sleeping is off. Then we have the motor going right, so it comes left and it goes right. I sleep for 1 second, and that is causing the problem, and that may be a very big problem even, because how long does it even take to reach 7? It is heavy, and it today it got even heavier because of the cable guidance necessary to keep the wire out of the blades, the propeller blades, and the very fast movement there was in the beginning has certainly gone now, even with 2 motors. Is it wise to have propellers? I don't see why not. But in these circumstances, I can easily put it to 6. However, in comes this one. If T digital 6 I think it has to be used, because this is only the timing that the motor is there. If the motor is not there, this goes. So I think I should reduce this one. Then T-digital 6 goes. The motor. And then we have an if. If their status, I think this is important. If their status is 1, then write 7 for how many seconds? At least 6. But I need to do it like this. Oops. Yes. And then an if also for 0. So now it is time to put their status 0, which is towards the controller. Must be left. And I'm not quite sure this should be there, but if the status is 0, then whatever. Set output 1, 0. And the yes, and then status should become 0 if only sleep 6 their status change to 0 should happen only after this. Their status to 1 should happen after this. Then we have not, if not digital 6, so the carriage is present at its location, and I can keep it for 3 seconds. In total it would be 9 seconds, but given the lack of speed, there may be not even 9 seconds is maybe not even enough for getting towards 7. So T-digital 8 is positive. Not T-digital 8 means that the carriage is right there. And if the light beam at T-digital 7, which is in the middle, is interrupted, if the direction is towards the controller, keep moving for 3 seconds. If it is from the controller, away from the controller, also sleep for 3 seconds. Is there any more to consider? Well, yes, actually there is, because if you look here at the set outputs, which are lens lamps, they are sleeping for 2 seconds And the very question is that enough? It sleeps for 2 seconds, it goes off, and I think that is a problem. I think I will have to put these lamps also in here, for the very reason that this and 7 and 6 depend on the activation of the lamps, and if those are not activated, all these ifs, all the digital ifs are actually completely void. So that's something to consider as well. Where do I put them? I let them sleep for 2 seconds, then they go off, and it tests if it is there. Well, there's nothing to see. Very nice one. How to keep them alive? Not quite sure actually. And a very short test reveals that although the code is okay, the timing is not. So when I start the program, what happens is that it comes towards the controller, then it goes, but it moves so slow that the light beam is no longer interrupted, but it holds on. So the 6 seconds may just as well be 12 seconds. And that is a problem. You may hear the rattling noise of the propeller hitting the support, and then it hesitates because the light beam comes through again. It changes, so I really need to change something with that. Dear status not 6 is 1. That is something I have to change as well. I have to know what status is. So I am copying this, and this is the 6, and then this is the 6 at 0, and this way I know which is which, or anyway I should know this. So let's check again. It comes towards the support again. It's 0 now. It comes, and that's very logical that it says not, because the wires are not, the lamps are not burning, and that is exactly the problem that I had just in the last segment. How to solve this? This line only keeps the lamps burning for 2 seconds, and then it tests on if T digital 8 and T digital 8, no, T digital 6 is coming from output. Let me be very clear on this. This is output 2. So this one is lamp 8. No, lamp 6. This is lamp 6. And it shines with output with intensity 6, but that's not it. So that is a problem for now I have to solve. Timing, as well as how do I make the lights, the lens lamps, shine when is necessary. Wiring problem solved. The ground power solved. The secondary motor suspension or connection solved, but the code is not solved yet. So with that, thank you for watching. If you like this video and my other videos on this subject or other project videos, please subscribe to my channel if you haven't done so. If you like to support in some way, please see my website for more information how you can donate. And please see also my Instagram, and this is to be continued with most likely, well, very surely, software, because that's the big issue remaining, apart from new experiments. So bye bye.